Assalamu alaikum dear friends. Welcome to the lecture of the quantum mechanics. In this lecture we will discuss about the probability interpretations and normalization. What is how the probability is interpreted. For example, last time we were discussed about the wave function. A wave function is the complex quantity which describe the state of any particles in quantum mechanics. But this wave function is complex in number. For example, it may be a sine of x. Its wave function may be a exponential iota kx minus omega t, may be sum of sine and cosine, and also pure exponential function, or maybe any type of wave function which is acceptable. So this wave function does not tell about anything physically. If we take this complex conjugate and add modulus square, that will give us the probability. For example, the probability interpretation tell us psi mod square dx, mean probability in from probability in the length dx. If we want to find the probability psi mod square in the volume, so it will be delta v, and give us the probability for finding the particle between x and x plus dx. To find the probability that the particle is located within a given region x, we integrate. For example, definition: finding the probability a particle is located in the given range, in the range from a to b. If we want to find the probabilities of a particle which is located between this range, so probability will be just equal to probability is a to b psi mod square and dx. Probability between a to b psi mod square dx will be equal to just like this. It is common to denote the probability density psi of modulus square with rho of xt, because this is the probability. If this dx is divided on the other side, so probability divided by, for example, x, it will be equal to probability density. For example, we have a numerical type problems which says that suppose that is suppose that at certain probability distribution given by p of x is equal to 9 over 4 x cube for region 1 to 3. Find the probability that 5 over 2 is less than x less than 3. Find the probability. Okay, so probability is equal to 9 over 4 over x cube. We have to find the probability between this region. So 5 over 2 to 3. So 5 over 2 say to 3, and the wave function is 1 over x cube 9 over 4. So 9 over 4 just putting into this expression, so it will become 9 over 4 1 over x cube dx from the given limits. If we integrate this equation just, so this will give 11 over 200, which is 0.005. If this were a wave function, there would be 0.5% chance of finding the particle between this. So it's means that the probability for this wave function between this region is equal to 0.055, mean 5.5% probability of finding the particle in this. And similarly, next we know that in the universe particle can be found in the one place. For example, the probability must sum to 1. What does it mean? The total probability for any distribution must be summed to unity, mean either particle is located at one point, either particle is located at other points. So the finding of particle probability will be at one place. For example, if particle is here, so it will 0 probability to find at this point. Similarly, if the particle is here, so it will have 0 probability in this place and in this, because particle is here. So the total probability, if the probability distribution is discrete with n individual probabilities, so this means the sum of all probability is equal to 1. For example, it means this particles may be found here, particle may be found here. So 50% chance at this point and 50% chance at this point. If we have 4 position, for example, particle can be located in any this point. So 25% here, 25% here, and 25% chance here, and 25% chance here. So sum of all the probabilities should be equal to 1, means sum of all the probability for discrete. If this is not discrete, for example, for a continuous we will have For continuous probability distribution rho of x, the probability must sum to infinity. So for continuous we use integration in the place of summation, so it will be equal to minus infinity to plus infinity, and rho of x and dx is equal to 1. So we will integrate this and it should give is equal to 1. In the quantum mechanics, this condition must that the particle is located somewhere in space. So in the quantum mechanics, we write this minus into infinity. This will be the psi of modulus square dx is equal to 1. As we saw in the solution to the square well, a wave function that solves the Schrodinger equation is determined up to known constant. Okay, so in solving the Schrodinger equation, we will need a wave function that solves the Schrodinger equation to unknown constant. So finding the unknown constant, for example, if we have psi of x is equal to a sine kx. So first what we'll do, we will apply this condition. So the particle is located in one point, so particle probability, so it will be write this minus infinity to infinity psi modulus square and dx and put equal to 1. So we just take its modulus and multiply with this will give us some modulus square and put in this equation, and we will put this whole integral equal to 1 because this is the whole probability, and the probability of finding the particle is equal to 1 because this is the total probability and the total probability is equal to 1, and through this we can find this normalization constant because we can evaluate this integral, and this constant can be taken outside, and thus we can solve for this unknown constant. Like in the next question, how we can find the normalized constants. Example, the wave function of particles found between 0 to a in the ground state was found to be this: psi of x is equal to a sine pi x over a, and a is the normalization constant which we need to find. Normalization constant. Find a and determine the probability that the particle is found in the interval this. First we will find a as the above described method. So we are given with the psi of x. If we try to solve this for normalization constant, it will give the so normalization condition is minus infinity to infinity psi mod square dx is equal to 1 because the particle can be located at one place. So the total probability sum of all the probabilities should be equal to 1 if we have discrete wave function. So we are given with the wave function psi of x is equal to a sine pi x over a. We will just take its complex conjugate, psi square is equal to a modulus sine pi x over a. Just multiplying these two, so it will give psi steric of x which is equal to psi mod square x, and just plugging these values, so it will give a and a mod square and sine square pi x over a, like in this sine square pi x over a, and 0 to a is the given limit dx. We just integrate this by taking this constant outside, a square 0 to a sine square pi x over a, and putting equal this whole term to equal. Now the this we have to evaluate this integral. If we evaluate this integral, the value of this integral will be divided on the other side of this equation, like this sine square u is equal to 1 minus cos 2 mu over 2. To write the integral, we can write this integral like this. So a square 0 to a sine square pi x over a dx. If we put u is equal to pi x over a, we can convert this integral into this one, because sine square mu is equal to 1 minus cos 2 mu over mu. So 1 minus cos 2 pi x over a over 2 into dx. Now we can write this integral as a sum of two numbers, because this divided by this and this whole term divided by this term. So a square to 0 to a dx minus a square over 2 cos 2 pi x over a into dx. Then a square over 2, we can integrate this, very simple integration. Similarly, we can integrate this plus cos of integral of cos is just sine, so this will go to 0, because you know that this integral of sine x as cos x is equal to 0, so this will go to 0, and integral of this should be equal to 1. Just integrate this and find the value of a like this. So the first term can be integrated easily because this term can be integrated easily and this will be equal to 0. So a square root of 0 to a dx is equal to this. And for the second term, let u is equal to 2 pi x. So we can just integrate this whole term like at this point, and we have found that this is equal to 0. Anyhow, this the integral of this sine and cos. You should remember this integral of sine and cos. Sine 2 pi x over a, this is equal to 0. Integral of 2 pi cos 2 pi x over a, integral of this is 0 over the period 0 to a. If we integrate this, we can integrate by using this simple mathematical technique, and is equal to 0. So this term is equal to 0, and this is equal to a square over 2 a over 2. Okay, so the only first term is contributing in this our expression. So it will be equal to psi mod square dx is equal to a square over 2 into a. We can find the value of a from this expression because this other term goes on the other side. So it will be equal to 2 under root pi, because a square over 2 a is equal to this. So this will multiply this on the other side, and now we have found a. So just plug this a sine pi x over a, just plug the value at this. So it will give 2 over under root 2 over a sine pi x over a. Then if we have to find the probability between a over 2 and 3 over a over 4, we can find the probability. So probability between two states will be equal to a over 2 3 over 4 sine mod square dx. We have normalized wave function, which is now this, because we have found the normalization constant. So under root 2 over a, just we can take this complex conjugate to find the psi mod square. Its complex conjugate will be equal to under root 2 over a sine pi x over a, and we have psi of x, which is equal to under root 2 over a sine pi x over a. If we just multiply these two numbers, psi and psi mod square, it will be equal to psi modulus square, and just multiply in a similar way we will multiply this two number on the right side. So if we multiply these things on the left side, just we have to multiply this on the right side. So this will become 2 over a sine square pi x over 2 when to multiply these two terms as in this. So just integrate this equation 1 minus cos 2s. We can write it separately, and integrating this, you know that integral of this will be equal to just x, and putting the upper and lower values, and similarly we can integrate this. Integral of this will be equal to sine 2 pi x over a and 1 over 2 pi. Just evaluating the lower and the upper value of the limits, we will have this 1 over a 3 over 4 minus this and these whole terms. Okay, so this will give us pi plus 2 over 4 pi 0.41. So we have 41% probabilities of particle finding at this point. Similarly, we have another example 2.7. Find a and b so that phi of x is equal to a and bx between 0 to a and a to b. We can find this normalization constant a and b by using the above described method. So just you can see and solve it. Okay, the first integral phi of x square dx is equal to this between the given limit 0 to a square plus a to b. We have b square x, because now minus infinity to infinity phi of x square dx. So from 0 to a we have function a square dx, as you are observing this question. From 0 to a we have a function a. So we will just write 0 to a. First phi square is from 0 to a we have a square, so a square into dx, and then a to b we have bx, so it will be equal to b square and x square into dx and equal to 1. So we will evaluate this separately, and this will give answer like this: a square plus this, and then you can integrate this a square plus whole term and find the value of a. This will be this complex number, and then we can find the this value of a, this whole term. Okay, similarly We have another question. Normalize the wave function psi of x is equal to c over x square plus a square. We can find the value of c but just above normalization method. I will just show you the whole mathematics. First, psi of mod square dx is equal to this, and then put into our required expression, because you know that minus infinity to infinity psi mod square dx should be equal to 1. So we have psi mod square which is equal to this constant can be taken outside, and we have to integrate this whole integral, and integral of this is equal to this. You can see that 1 over 2a square and this. Okay, and just you can see the whole integrations. It is a game of integration and you can evaluate it like this. So it will give us psi of x is equal to 2a cube over pi 1 over x square plus a square. I have just uh, ignored this all of the time because this is very simple mathematics. If you are good at mathematics, you can solve this. So I will stop at this point and will continue from this point onwards.